Welcome to your first video for statistics. You're going to view a video every night for homework. As you watch, obviously you are expected to take down the notes that you see that appear. Also, throughout the video, you're going to have questions that pop up. They might be multiple choice, they might ask you to solve something, it might just ask you to answer a basic vocabulary kind of question. You'll want to use what you've learned so far in your notes to apply when solving these. The main reason for that, these will be worth points towards your notes grade. So accuracy is important, so make sure you take your time and you understand the question. If, when you're finished, you get something wrong in the question, but maybe you understand, you can explain what you did wrong. You can find your math error or something like that. There is a space for you to explain your error. That at least shows me some of your understanding in what you did wrong and might improve your grade. So let's take a look at our first video. We're starting with Chapter 2. Chapter 2 is focused primarily on the concept of what is data and how to understand, explain data, categorize data, etc. So here is some numbers: 17, 21, 44, and 76. So the first question becomes, are these data values? And the answer to that is no. The context of your data is the most critical piece of your data. We don't know what these numbers represent. They could be test scores, they could be ages in a golf foursome, they could be the uniform numbers of the starting lineup for the St. Louis Cardinals. So without that context, we can't categorize them as data. The best we can say is they are simply numbers. So, are these data? No. That context, what do they represent, is absolutely crucial. So then, what is data? So data can be numbers, they can be record names or other types of labels. They don't have to be numbers. Not all data that's represented by numbers has to be numerical. If we're talking about height, yes, those numbers are going to be numerical and they're going to mean something numerical. If we talk about age, same thing. But in some surveys, you want all of your data to be numbers simply because it makes it easier for sorting and everything. But the number 1 might represent males and the number 2 represent females. So when you're, again, analyzing data, look at what the numbers represent. You have to know their context. Okay, context is extremely important for data, so make sure you always understand context. So context has 6 very key pieces. So the first key piece is who. We also have what, specifically in what units. We have a when, where, why, and how. Now you might be thinking those are words that we've learned in English, and you're absolutely correct. Those are words that are very commonly used in English class. We're going to be applying them to data. So we're going to take several slides here. We're going to break these down. What do we mean a little bit more in detail about who, what, when, where, why, and how? So the first thing we're going to look at is the who and the what. So the who of the data. Who are the individuals that are being measured or counted? And I want you to understand that we use the word individuals very loosely. Individuals don't have to be people. They can be objects, they can be animals. It's just, that's the term that we use for the thing that we are measuring or counting. So who is, what are we focused on? What? What is the next important piece of data analysis? What has been measured or counted, and if it has been measured, what units? So what's going to be things like, if we're talking about people, age, height, race, gender, those are all things that can be measured about someone. If you're measuring height, you might be talking about the unit of inches. If you're measuring weight, it might be pounds. So those are what we mean by units. Now let's look at the when and the where. So the when. The when is pretty self-explanatory. When was the data recorded? Was it recorded in the 1800s? Was it recorded last week? Because when the data is recorded definitely can make a big difference. If we're talking about ages, the average life expectancy of someone in the 1800s was much shorter than now because modern medicine has changed. So knowing the when of the data is very important. We also need to know where. Where was the data recorded? Was it recorded simply here in Hazelwood? Was it recorded covering the entire United States? Was it a totally different country like Tanzania? Because again, that adds to the context of the data. And the last two. Why was the data collected? This can sometimes be the most revealing piece of information. Why did we collect this data? Was it to analyze trends? Was it to compare historical versus current data? And then finally, how was the data collected? Was it collected via a phone interview? Was it collected by sending out a survey in the mail? Was it collected online? Was it collected in person? These can all tell you something about the data, how accurate it is. Is it truthful data? Because those are things that are important with data analysis. Now, typically when we collect data, we tend to organize data in a table. A data table is simply an arrangement of the data in which each row, and remember rows go horizontally, represent a case or an individual, and each column represents a variable. Now, the columns are the whats. So when we think of the word what, you will hear the word variable associated with our whats. The rows will tell us the who. So each row is a separate who or individual that we are studying. Now, usually the who of the data is the leftmost column. Not always, but that is usually. Usually we state the who's first, whether it's people or animals or whatever it is that we're collecting. That's typically your first column. Now we have a few more vocab words here. The who of the data tells us the individual cases for which or whom we've collected. There's three basic types of cases. The first type of case that we will study are respondents. Respondents are actually people because they are being asked to answer a survey question, and only people are able to actually give you a verbal answer or a written response. The next type of case that we will be studying are subjects or participants. That word is used interchangeably. These are people on whom we experiment. Okay, so we see some differences here. Respondents were people who were simply answering a survey. Subjects or participants are people on whom we do some sort of experiment. Now, we're not necessarily talking a chemical experiment. You could just be measuring and weighing different pieces of them, but we somehow interact with them more physically speaking. Then our last category of cases are experimental units. These are everything else that are not people. They could be animals, plants, or any other inanimate object, but these are not people. So respondents are people who answer a survey, subjects or participants are people on whom we experiment, and then everything else that's used are just experimental units. So let's take a look at our first data table. So the following data table clearly shows the content of the data being presented. We just want to name a couple of things. We want to name who is being discussed in this data and what are we discussing about them. So one of the things I said was typically your first column are your who's. So if we look at our first column, the first thing we see are purchase order. And that is exactly what the who's are. The who's are purchase orders. This is an inanimate object, but it is something that we can study. Now, what did we study about the purchase orders? Well, on the previous slides, we talked about your what's are your variables. They are your other columns. Well, if we look at our other columns, we have a ship to, a price, was it a gift, an ASIN, and an artist. By the way, an ASIN is just a code that's specific to a product. So those just happen to be the what's. We wanted to know about each purchase order. Where was it shipped to? What was the price of the purchase order? Was the purchase order a gift? What's that unique code that is associated with it? And in this case, the purchase orders must have been CDs because these are artists like Kansas, Boston, Chicago, and Garbage. Older artists, but they are artists. So when we're talking about who are we studying? What are we studying about each one of them? Let's look at some other vocab words that are applicable to data. So the first one is population. You'll hear this used a lot. The population is the entire group that we are interested in knowing something about. So it's the entire group that we want to survey. Now, it doesn't mean that we're talking about the entire population of the United States. The population, if we're only interested in students at Hazelwood West High School, the population is simply all of the students at Hazelwood West High School. A sample, this is a small group from the population. So let's go back to the Hazelwood West population. If the Hazelwood West is our population, we might take a small group from West to survey. We might take a few of each grade level. We might just survey the seniors or just the freshmen. So a sample is a small group from the large group. And variables, which we've already heard briefly explained, but this is to be more specific. The variables are the characteristics of each individual case that we are studying. So they are the what's. What is your age? What is your height? What is your weight? What is your gender? Again, if we're talking about people. So this is just some more information about variables. Variables are characteristics recorded about each individual, like we just said. The variables should have a name and identify what has been measured. If we're counting height, height is considered the name of the variable, and then the numbers for each person's height go with each person. To understand the variables, you must think about what you want to know. What is it that we are trying to study? Because if we're wanting to study GPAs about our students, well, height doesn't really have anything to do with GPA. Their courses that they've taken, the grades that they've gotten, maybe whether they're honors courses or not, those are things that would relate. And some variables have units that tell us how each value has been measured and the scale of the measurement. Not everything has to have a unit, but for instance, height, its value is going to have a unit so that we know what scale we measured on. Is it inches? Is it centimeters? Is it feet? Same thing with weight. But gender, male and female, that's definitely a variable, but it doesn't have a specific measurement scale because it's just a variable. Now, variables can be divided into two different categories. The first category is what we call categorical or qualitative. You'll hear both used, but we do use categorical more often. These are naming categories. You can use either words or numerals, but they are naming something. They answer questions about how cases fall into categories. So, examples of categories: what's your sex? What's your race? What's your ethnicity? What's your favorite pizza topping? What is your year in high school? So those are all things that put you into a category. And again, thinking about year of high school, someone could say freshman or they could say ninth grade. So freshman is the word version, ninth grade is the numerical version, but they're still categories. The other type of variable is a quantitative variable. These measure variables and they must have some sort of unit. They typically answer questions about the quantity of what is being measured. So, for instance, income, we measure it in dollars. Height, we might measure in inches. Weight, we might measure in pounds. Other types of quantitative variables. Age. Well, if you ask somebody how old are you, their units are years. So all quantitative variables have to have some sort of units attached to them. So we have an example here. In a student evaluation of instruction at a large university, one question asked students the following. Evaluate this statement. The instructor was generally interested in teaching. And you're answering it on the following scale. 1, disagree strongly. 2 is just disagree. 3 is neutral. 4 is agree. 5 is agree strongly. So, is interested in teaching categorical or quantitative? Because you're answering with numbers. But the question becomes, do these numbers have a unit that you can attach to them? Disagree strongly? There's no unit for that. It's not like inches or pounds. It's just a statement. So even though people are answering with a 1, 2, 3, 4, or 5, which makes it numerical, because you cannot attach an understandable unit to it, these are categorical. This is a categorical question, and the data that we collect is categorical data. Let's look at 2 more vocab words. First vocab word is that of an ordinal variable. An ordinal variable is a variable with no natural unit, but still a ranking or order to the responses. So first, second, third, or highest and lowest. Those are ranking words, but they don't necessarily have a unit attached to them. To decide if something is ordinal, always look at the why. Why did we gather this data? If it was to rank someone, then it's an ordinal data. And then the other kind of oddball variable is that called an identifier variable. This is a categorical variable with exactly one individual in each category. So for example, Social Security numbers are the most common identifier variables. Every single human being that's born in the US is given a Social Security number. That is a number that is unique to them and them only. They are the only individual that has that number. That's why it's an identifier variable. An ISBN, those are identifier variables specifically for books. FedEx tracking numbers, if you send a package via FedEx, there's going to be a tracking number associated with it. Those are also individual to that package. These kind of variables, you can't analyze them. You can't take the mean or the median of these data. Usually they are numbers, but you can't analyze them. And not all variables with one case are necessarily identical identifier variables. Keep in mind, they have to identify an individual or some sort of object. And so that's the end of the first video. Obviously, you've answered a couple of questions along the way. The homework that you see listed here, that is not your homework tonight. When you come to class tomorrow, this will be what you will be working on in class. You'll have a chance to work with your group members. You'll have a chance to ask me questions, perhaps about the video if there was something you got stuck on, or as you're going through the homework, what did I not understand? You'll also have a chance to check your answers, and that assignment then will be due in class tomorrow. So you'll have 90 minutes to work on this assignment. So don't worry about starting it now. And we will see you in class.